morning, students. Now we are learning our first lesson, laws of motion. Students, in our last online class, we have seen about impulse and Newton's third law of motion. Let me once again recall shortly about impulse. So what is impulse? Larger force acting for a short period of time. Large force acting for very short interval of time is called impulsive force, and then it is denoted by the symbol J equal to F into T. J equal to F into T. So this is impulsive, and then there are two ways we can achieve impulse. First one is large force acting for a short period of time, and then second one is smaller force acting for a longer period of time. And then second one is Newton's third law. You are all very well known about Newton's third law. For every action there is an equal and a opposite reaction, and then they always act on two different bodies. So this is Newton's third law. And then one example, very important example, when birds fly, they push their air downwards with their wings. That is action. And the air pushes the bird upwards, reaction. So this is example for Newton's third law. Students, now we are going to learn our today's topic, principle of conservation of linear momentum. So you know that what is mean by linear momentum. So the object which are travel in straight line is said to be as linear momentum. And then in this topic they given conservation. Conservation meaning what? Saving. So there is no any loss in the system of linear momentum before collision and after collision. So in this topic we are going to learn about conservation of linear momentum. So there is no change. There is no change in linear momentum of a system when no external net force act on the body. Students, let us prove the law of conservation of linear momentum with the following illustration. So consider two bodies A and B having masses m1 and m2 and move with initial velocity. Initial velocity u1 and u2 in a straight line. Let the velocity of the first body be higher than the velocity of the second body. Here first body is m1 and second body is m2. So m1 have greater velocity than the m2. During an interval of time t second, they tend to have a collision. So both m1 and m2 are collide with each other. After the impact, both them move along the same straight line. So this is the picture after collision. both m1 and m2 move along the same straight line with the velocity v1 and v2. So here v1 and v2 are mean for final velocity, and then u1 and u2 mean for initial velocity. So force on body be due to force on body be due to A, because according to Newton's second law, for every action there is equal and opposite reaction. So here m1 force is transferred to m2, and then m2 exert equal and opposite reaction on m1. So force on body be due to A, Fa equal to m2 v2 minus u2 divided by T. So here the proof is given, and then force on body be due to A. So Fa equal to m2 v2 minus u2 divided by T, and then force on body A due to B, and then it is given as Fb equal to m1 v1 minus u1 divided by T. By Newton's third law of motion, action force equal to reaction force. So action force Fb equal to reaction force minus Fa. So here we going to substitute the values for Fb and Fa. So what is the value for Fa? m2 v2 minus u2 divided by T. So here we going to write that value, and then Fb equal to m1 v1 minus u1 divided by T. So left side we going to write the Fb value, and also we have to write the negative sign, and then here T is constant for both the term, so we going to cancel the T term is cancelled here. So the equation is changes m1 v1 plus m2 v2 equal to m1 into u1 plus m2 into u2. Students, from the above equation confirms in the absence of an external force, the algebraic sum. What is mean by algebraic sum? Adding with the plus and minus symbol. The algebraic sum of momentum after collision is numerically equal to the sum of the momentum before collision. So hence the law of conservation of linear momentum is proved. Students, let me once again explain the concept principle of law of conservation of linear momentum. So here there are two masses m1, m2 traveling with the initial velocity u1 and u2. So here u1 is greater than u2. So m1 velocity is greater than m2 velocity. So after small or short time interval, both the mass m1, m2 collide with each other with a force Fa, Fb, and then they move along a straight line with the velocity v1 and v2. So here there are two laws substitute in the law of conservation of linear momentum. The first one is Newton's second law and Newton's third law. Because we know that F equal to m into A, and then we know that acceleration equal to rate of change of velocity, A equal to v minus u divided by t. So we going to substitute this value in A. Let us come to our equation. So force on body B due to A. In this picture, the force on body B. So this is body B and this is body A. So force on body B due to A. So here we going to write Fa equal to m2 v2 minus u2 divided by t, and then force on body A due to B. Here FB equal to m1 v1 minus u1 divided by t. So in this two term, t is common. So we going to cancel the term t. And then according to Newton's third law, by Newton's third law, action force equal to reaction force. Here action force FB equal to minus FA. The force on body B due to A is action. The force on body A due to B is reaction. Hence here we are writing FB as a action and FA as a reaction. Now we are going to substitute the value for FB and FA. For FB, M1 V1 minus U1 equal to minus FA value M2 V2 minus U2, and then we going to multiply the values M1 into V1 and then M1 into U1. So M1 V1 minus M1 U1 equal to, here minus M2 into V2 minus M2 V2, and then minus into minus plus, here one minus sign and then here one minus sign, so it changes into plus, minus into minus plus, so plus M2 U2. Now we going to take initial value one side and then final value in M1 V1, and then in the right side here M2 V2 is in negative sign, so it will come as positive sign, plus M2 V2 equal to, here M1 U1 is in minus sign, when it come to right side it will changes plus sign, so I am taking this term into right side, so M1 U1 plus M2 U2, and then we can interchange this term as M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. So initial velocity and final velocity are equal in both the term. Students, from the equation we confirm that absence of an external force, the algebraic sum of momentum after collision is numerically equal to sum of the momentum of before collision. So this question is very important question. Principle of conservation of linear momentum. So kindly, carefully go through the topic and you have to write it in your classwork note.